So starting off with what is polarization? We are going to understand what is meant by plane polarization and then describe how polarization can be used with models to investigate stresses in structures. So what is plane polarization? Transverse wave है oscillations at right angles to the direction of motion. Transverse wave कौन सी होती है? ये तुम्हें पता है कि अगर वेव इस डायरेक्शन में ट्रेवल कर रही है तो जो पार्टिकल्स होते हैं दे आर ऑलवेज 90 degree perpendicular to the motion. In many cases, the planes of these oscillations might be fixed in one fixed orientation, and figure A shows the electric and magnetic fields in an electromagnetic wave. In this example of a light wave, the electric fields only oscillate in the vertical plane, and the wave is said to be plane polarized, or more precisely, vertically plane polarized. For electromagnetic waves, the plane of the electric field's oscillation is the one that defines its polarization. Often many waves travel together with oscillations in a variety of planes. अब different plane के अंदर इसने oscillate करना है. Let's say अगर एक wave ऐसे oscillate कर रही है, ठीक है, on this particular axis, अब एक और wave आएगी जो थोड़ा सा टेढ़ा oscillate कर रही है, a little diagonally, but at a different plane and 90 degree to the other one. आप इसको 3D image समझो कि एक आंख पास इस तरह करके oscillate करी है और दूसरी इस तरह करके आ रही है. इट्स अ डिफरेंट प्लेन, एक लेट गई है बिल्कुल. Often many waves travel together with oscillations in a variety of planes. In this case, light from this source is said to be unpolarized, and this is how light emerges from a light bulb, a candle, and the sun. Polarization is only possible with transverse wave. याद रखें longitudinal waves polarize नहीं हो सकती because they are always moving. उसके जो molecules होते हैं वो parallel to the wave motion oscillate कर रहे होते हैं, तो जरूरी है कि that should be a transverse wave.
ऑसिलेट भी
Polarizing
नहीं
filters
करते।
भी क्या होते हैं? Unpolarized radiation can be passed through a filter that will transmit only those waves that are polarized in particular plane. अगर आपके पास एक polarized filter जो vertical है, अब सिर्फ वही वाली वेव पास करेगी जो वर्टिकली आ रही थी. ठीक है, अब दो वेव्स आ रही है, एक हॉरिजॉन्टली आ रही थी, ये तो इसमें से पास नहीं करेगी, सिर्फ वही पास करी है. दैट इज फॉर एग्जांपल, जैसे आप एक सिम कार्ड होता है, ठीक है, एक सिम कार्ड को उसी स्लिट में डालोगे, उल्टा करके तो नहीं डाल सकते. अगर सिम कार्ड का स्लॉट ऐसे है तो सिम कार्ड भी आप ऐसे ही डालोगे, ये तो नहीं कि आप इसको बिल्कुल वर्टिकली अंदर डालने की कोशिश करोगे. Only if they are in line with the slit. For light waves, the polarizer is a piece of plastic soaked with chemicals with long chain molecules such as Polaroid sheet. The Polaroid filter will only allow the light waves to pass if their electric field oscillations are oriented in one direction. So, figure B over here illustrates the effect of Polaroid filters on light from a bulb. अब एक बल्ब ने कितनी डायरेक्शंस में, ये देखो, 7-8 डायरेक्शंस के अंदर वाइब्रेट किए, बट पास कौन सी हुई है? सिर्फ दिस वन. ओनली दिस वन पास्ड थ्रू द फिल्टर. व्हाई? बिकॉज इट वाज द एग्जैक्ट शेप in line with the filter as well. The rest of the waves, this one, this one, this one, this one, this one, and this one, these did not pass. Which one passed? The only vertical line which was in line with the filter slit as well. So figure B illustrates the effects of polarized filters on light from a bulb. It starts unpolarized with vibrations in all directions. शुरू में unpolarized थी. The first filter only permits vertical vibrations so that they are selected and the light is transmitted vertically plane polarized. The second filter is oriented in the same vertical direction and the light will pass through this without change again. The third filter is oriented. अब क्या हुआ, जो थर्ड फिल्टर था ना, दैट इज हॉरिजॉन्टल, और ये वर्टिकल वाली एक ही लाइन आई थी, इट कैन नॉट पास थ्रू, तो यहाँ पे देयर वुड बी नो वाइब्रेशंस एनी मोर. इज इट क्लियर?
जी।
So the third polarized filter is oriented horizontally, and this blocks the vertically polarized light, and so no waves are transmitted beyond it. The second and third filters are referred to as crossed polarized, as the orientations are at right angles, and together they will always block all of the light. Now, how is this polarization done? By reflection and refraction. When unpolarized light reflects from a surface such as a road, the waves will become polarized as well. Now, the degree of the polarization depends on the angle of incident, कि वो किस angle से incident हो रहा था. But it will always be tending towards horizontal plane polarization. For example, figure E में आप देखो, यहाँ पे भी यही हो रहा है. ठीक है, रिफ्लेक्टेड रे आ रही थी, लेकिन अब वर्टिकल वाली डिड नॉट पास. सिर्फ जो हॉरिजॉन्टली आ रही थी ना, ओनली दे रिफ्लेक्टेड, और हॉरिजॉन्टली वाली ही गई थी. जो वर्टिकली आ रही थी, दे कैंसल आउट 90 डिग्री टू द प्लेन सरफेस, क्योंकि सरफेस सीधी है, सीधी सरफेस के ऊपर सीधी वाली लाइंस ही आपके पास रिफ्लेक्ट कर दी, बट द स्ट्रेट लाइंस डिड नॉट रिफ्लेक्ट polarized. The polarized filters will block light that is horizontally polarized. If a driver has these, then they will block the polarized light reflected from the road. This will make it easier for the driver to see clearly. तो आपको polarized glasses भी आती है. Now here you can see different waves, ठीक है. Now this is an incident ray. अब surface इस तरह से है. This is the shape of the surface which is horizontal. That means that only horizontal one would be reflected. Got it?
जी.
वही रिफ्रैक्ट होगी और वही रिफ्लेक्ट होगी. ये भी एक तरह से रिफ्रैक्शन भी पोलराइज कर सकती है वेव्स को. फिर chemical solutions can also do the job. Analysis of stress concentration investigated above works because different parts of the plastic model have different effects on polarized light. This is also the case with some chemicals such as sugar solution, where the amount of the concentration of the sugar solution varies the angle to which it rotates the polarization of the light. We can use the Polaroid filters to analyze the strength of the sugar solution by measuring the angle at which the light polarization emerges after passing through the solution. Different solutions भी हैं जहाँ पे आपके पास वेव की स्ट्रेंथ और polarization भी हो सकती है. So how do you define polarization? It is the orientation of the plane of oscillation of a transverse wave, and if the wave is plane polarized, all its oscillations occur in the single plane. Got it?
जी.
Hi guys! In this video we're going to be looking at plane polarization, polarization of a wave through a slit, and we're going to finish with a summary. So we're going to start off by introducing the idea of plane polarization and to try and understand what we mean by a polarized wave. We know that the direction of oscillation in a transverse wave is perpendicular to the direction of propagation. So for example, for this wave here, we can see that the direction of oscillation is this way. So if we're looking at the page, it's up and down the page. That's the direction of oscillation. And we know that the direction of propagation is perpendicular to the direction of oscillation. So the direction of propagation is this way of the wave. So they're both perpendicular to each other. And remember, when defining the direction of propagation, it's hard to tell by just looking at the wave. So usually we define it as one direction or the other, just making sure that it's perpendicular to the direction of oscillation.
And we're back in third quarter planning. Adams is quarterbacking this project and...
But now, imagine we view the wave from a different perspective, where the direction of propagation is either into or out of the plane of the screen. So let's imagine that we're this person here, and this is the angle that we're viewing the wave from. So if we're viewing the wave from this perspective, we can see that the direction of oscillation is going to be up and down like this. From what we can see of the wave, that's what it appears to be. And we know that the direction of propagation is out of the screen, so it's like the wave is coming towards you. In this point of view, we can see that the direction of oscillation of a transverse wave could be along any angle or even rotate with time. So we're saying here that the direction of propagation is out of the screen. So that means the direction of propagation is actually perpendicular to the plane of the screen. So this tells us that we could have lots of different directions of oscillation, provided that all the direction of oscillations are within the plane of the screen. So if we're imagining here that the wave is coming out towards us, then all these directions of oscillations that we've got, so this one and all of them, they're all actually perpendicular to the direction of propagation. So we can see that in fact we can have lots of different directions of oscillations for one particular direction of propagation. So each of these directions might be at different times. So this one might be at T1, this one at T2, this one at T3, and this one at T4. So this shows us that a transverse wave travelling in a certain direction can actually have lots of different directions of oscillation. Because remember, the way we defined a transverse wave is that the direction of oscillation is perpendicular to the direction of propagation. And we can see that we've actually got lots of different directions of oscillation that are perpendicular to the direction of propagation. Polarization is the term used to describe which planes the transverse waves oscillates in. The arrow indicates the plane of polarization. So the pink arrow here tells us the plane of polarization, and this blue arrow shows us the direction of propagation. And remember, we said the direction of propagation is coming out of the screen. So we're imagining that this here is our screen and our wave is coming out of the screen. So we can see here that we've got our transverse wave because it's oscillating perpendicular to the direction of propagation. And our plane of polarization is going into the screen. So this is our plane of polarization. It lies along this side here. And we can see that it's still perpendicular to the direction of propagation, which is why we've got a transverse wave. But now, rather than having all the different orientations of the wave, we've only got one. So we see that the wave has been polarized. If the direction of oscillation remains in one place, it is plane polarized or linearly polarized. So if this direction of oscillation stays in one place, then we can say that we've actually got a plane polarized wave. If the oscillation is in more than one plane, the wave is said to be unpolarized. So in this case, this is our direction of propagation. And remember, we said for a transverse wave that we have lots of different possible directions of oscillations. And that's what we've got here. We've got more than one possible oscillation direction that's perpendicular to the direction of propagation. So we've got this one here, this one, and this one. So they're all oscillations in different planes. So we say that this wave here is unpolarized. So now we're going to look at how we can polarize a wave through a slit. We can explain the polarization of all transverse waves by thinking about a wave traveling along a rope passing through a slit. So we're imagining that we're creating a wave on this rope. So let's imagine that we use this rope here to create a wave. So we can create a wave on a rope by moving our hand. And in order to investigate polarization, we can see what happens to this wave when it passes through a slit. An unpolarized wave passing through a slit of any orientation will be plane polarized after transmission. So before this wave passes through a slit, it's unpolarized. And this is because we can see it's oscillating at lots of different directions to its direction of propagation. So its direction of propagation is this way. But we have more than one direction of oscillation. So we've got this direction, this one, this one, this one, this one, and so on. So we can see that we've got lots of different directions of oscillation, so it's unpolarized. And we can see that once this wave passes through the slit, we've only got one direction of oscillation, this direction here. So we say that the wave has become linearly polarized. And we say that a wave is linearly polarized if it's only oscillating in one direction. If the slit is parallel to the plane of polarization, the wave passes through unaffected. So if the wave is already linearly polarized, so that the wave only oscillates in the same direction as the slit direction, and the slit direction is along this way, then the wave passes through unaffected. So we can see that it's still oscillating in its initial direction, and that hasn't changed. And that's because the slit direction is parallel to the plane of polarization of the wave. So the two are parallel to each other, which is why the wave goes through unaffected. If the slit is perpendicular to the plane of polarization, then the wave cannot pass through. So now our slit direction is this way, but now the plane of polarization of the wave is perpendicular to the slit direction. So we can see that again, the wave is initially linearly polarized. So it's already been polarized and it only oscillates in one direction. However, because this is perpendicular to the slit direction, that means no wave passes through. The slit blocks the wave. So we can see that the two are perpendicular, and this is the result we get.
And that is all for polarization and the end of your topic number 3C.